I would like to look at the initialization file for the Traverse system, which may need to be adjusted as you use the traversing system. So again, go through to the Windows Explorer. We need to look on My Computer, Drive C, Program Files, RMS. What we will find here is the executable, which is Traverse 2, and there's also an initialization file which is called TraverseINI. If we open that file, it'll open it up in a simple text editor. At the top you will find the definition of the indexer, which is the Traverse controller. The COM port is actually located by the program, so we don't need to specify what the COM port is, although in an earlier version I did, so that line is still in there. The actuator itself has got a name, and the Traverse controller reads the EEROM, which is the initialization string, from each of the two controllers. There's a radial one and a yaw one, and it should match the data that we see on here. If it doesn't match, it throws up a warning when you first start the program to say that it thinks there's something not quite right there. Next line, the radial encoder pulses per rev. This will always be 200. The radial motor steps per rev or pulses per rev is 100. Again, that's always going to be 100. The sync tolerance and the radial sync, the synchronization is where the controller monitors the encoder position against what it believes to be the current motor position, and if there's a discrepancy of more than 20 steps, then the axis will be stopped. This means that if there is a jam of some sort, then the axis will stop driving and prevent any potential damage. Now sometimes this isn't required, in which case the sync can be turned off and the motor will just continue to drive whether it's moving or not. Alternatively, if it's set to on, then this synchronization mechanism will be switched on. The next line is the PWM, or the pulse width modulation, which controls motor currents. Now we can set 4 possible values here. The first one is the current when the motor is accelerating, which is a very, very brief increase in current whilst the motor is getting going. The next one is the deceleration current, which again is a brief occurrence while the motor is changing speed and slowing down. The third is the running current, which is the current when the motor is actually turning, and the final one is the current when the motor is stopped, which is the holding current. So we can see there just a bit of information just as a reminder of what those numbers actually are. A value of 255 means that the current will be at 100% of its possible value. So 150 is a little over 1/2 of its current, and a value of 100 is a little under 1/2. Next one is the radial range. Again, that will always be set to 150 for this particular actuator. The gear ratio is 1. This is the ratio between the motor and the lead screw. Out limit is set to 0, in limit is set to 150. If these are manipulated, what it will mean is that the axis won't be able to travel beyond those numbers, and they will be software limits rather than physical limits. Radial home has been set to 20, so when the home button is pressed when the program's running, then the radial axis will return to 20 millimeters. Again, you may want to adjust that. Radial green band, this is the green area that is set on the radial display, which is set at 20. Again, this is purely for visual information, just so that you know when the axis is in a safe position and when the axis is inserted into the gas stream, and potentially could be a problem if anything went amiss. Again, you may want to adjust that just to give you a bit better visual indication while you're actually running the program. And the radial datum speed, you leave that at 5. Again, that's 5 millimeters a second, and that's the speed with which the axis will return to its datum point when the datum button is pressed. We've got a similar set of information for the yaw side, your encoder, your motor pulses per rev, your sync tolerance, and the sync tolerance on or off. And again, the yaw acceleration, deceleration, running and stopped. Next one is the yaw angle offset. You might notice actually that some of these lines have got an apostrophe in the front. If you put an apostrophe on the front, the line ends up being ignored, so it means you can put several lines that look very similar, but if you just enable one of them, then that will be the one that is used. The yaw angle offset, this is the numeric value that's added to the encoder result in order to position the 0 point of the yaw axis. So the yaw axis is datumed on the anti-clockwise limit switch, and so when it's found its datum position, that point is set to minus 86.4 degrees. What that means is that if we move clockwise 86.4 degrees, the display will indicate 0, and the yaw table will be in its mid position. The counterclockwise limit I've set as minus 85 degrees, and the clockwise limit I've set to plus 85 degrees. Again, these are somewhat arbitrary numbers. We also have the yaw green band minimum and the yaw green band maximum. I've set these to plus and minus 30 degrees. Again, it's just to give you a visual that the probe is pointing in the correct direction, which I'm sure you will already know. And the yaw home position is set to 0 degrees, and the yaw datum speed is set to 10 degrees per second. Again, those are quite reasonable numbers, no need to change these. Next couple of lines, these are folders that are located on drive D. The first one is the default location of the traverse tables. So when you try and load a traverse table, it will always look in this particular folder. Similarly, the event log data, which is data that is recorded during the process of a traversing operation, these will always be stored in the event log directory, and these are automatically recorded. You can't stop them, and they are identified by the date and the time at which they've been recorded. We'll have a look through some of those in due course. And that is about it. If you've changed it, remember to save it. We'll close it down, and that's it.